Good morning, sir.
Good morning, beta. So, uh, in the last class, I was discussing selection rules for beta decay. Selection rules for beta decay. Now, what is a beta decay process? If you ZXA, if you are having a nuclei ZXA, then it will convert into Y type of nuclei. I'm not writing Z and A because both will be covered here, plus beta plus और बीटा माइनस कोई एक, ठीक है, either beta plus or beta minus. If beta plus is there, it will be neutrino, electron neutrino, and if beta minus, this will be antineutrino. So combinedly, I can write like this. And I was saying that their combined L value is represented by capital L, and their combined state. This is considered as the combined state. This is called as combined state. Combined state of beta particle and neutrino. Beta particle and neutrino. Neutrino. Okay. So they are combined for the combined state. This is L vector for them plus this is the combined state spin. So I can call it as J. J. Okay, now this will be J, suppose. Here I'm saying that its angular momentum or spin state is Ji. Suppose parity is pi I. Its angular momentum state is JF or pi F. Pi F is the parity. So I'm assuming like this. So what will be my equation? What will be the conservation of angular momentum equation? That will be Ji. For conservation, Ji should be equal to this JF plus this J. J is the angular momentum of the combined state. And this J will be equal to L plus S. So I can also write it as Ji vector is equal to JF vector plus L vector plus S vector. This will be L vector plus S vector. This will be. Okay, so it will be like this. So here, this is the equation of the conservation of angular momentum for beta decay. More simplified. But what is L and S? L and S, they are the combined state. They are the combined state L value and S value. This is the combined state L value and S value. It will be like this. Now, we want to create selection rules. We want to create the table of the selection rule rather than. Okay? So two type of transitions were there. Fermi transitions corresponding to S equal to 0. So what I was saying, corresponding to S equal to S equal to 0, 0. This is capital S. Fermi transitions were there. If you remember in the last class, I tell you, Fermi transitions. Second for S is 1, GT transition. Remember this. Gamow-Taylor transition. GT means Gamow-Taylor transitions. Similarly, for L equal to 0, you were saying they are allowed transition. Allowed transitions. And L is equal to 1, 2, 3, or L is not equal to 0. They are called as forbidden transition. Why you are using word forbidden? Don't go by its name. It doesn't mean that they are not possible. They are possible, but less probable. They are less probable. They are called as forbidden because they are less probable as compared to allowed transition. As compared to allowed transitions. ठीक है ना? Forbidden transitions are less probable as compared to allowed transition. तो allowed transition के comparison में they are less probable. It is like this. ठीक है? Is it okay up to this point? ठीक है?
Yes, sir.
Okay. Now come back to this. Now I have to create a table. ठीक है? Now I have to create a table, complete table for all the selection rules so that I can tell you the given transition is which type. So I will write here, but right now I'm going to the next page. So here I want to write transition types. Transition types. I want to create a table. So here first I'm writing allowed transitions. So I'm writing allowed transitions. Allowed. ठीक है, या in even sometimes, okay, ठीक है, allowed transition. Then I'm writing first forbidden here. I'm going to write first forbidden. On what basis you call that they are allowed and they are, that is L value. So I'm writing here L value, L, just L value. So L will be 0 here. What will be L? L will be 1 here. So it will be like this. In this way, we are going to increase this table. This is L equal to 1. Then second forbidden will be there. Second forbidden. So that will be L equal to 2. Third forbidden. That will be L equal to 3. Then fourth forbidden. That is fourth forbidden. So that will be L equal to 4. L equal to 4. So in this way, I want to create the table. So corresponding to the values of L, okay, here corresponding to the values of L, we have tried to create a table. Now this is one type of one type of classification. Second type is Fermi type, ठीक है ना, or Gamow-Taylor type. So here first I am writing Fermi. Fermi transition means S is 0. ठीक है, so S is 0 will be here. And on this side, I will have GT transition. This will be GT. GT transition. If you are talking about GT transition, then this S will not be equal to, or S will be equal to 1. It will be like this. So in this way, we are going to classify it. Now there will be another parameter, not only because just directly observing by the equation, ठीक है, either you check S equal to 0, S equal to 1, L equal to 0, 1, 2, 3, or more simpler rules will be what will be the change, ठीक है ना, in J values. J values means delta J means what is the value of change in J for the parent and daughter nuclei. So what is delta J? Delta J, you can write somewhere that delta J is the change in J for the parent nuclei and daughter nuclei. So in parent nuclei and daughter nuclei, what will be the value of J? Delta J means Ji minus Jf or Jf minus Ji. Here this will be delta J. And second will be change in parity. What will be the change in parity? So in this way, we are going to classify delta pi. It will be. So we are going to classify in this way. Okay. Now we want to find out these rules one by one. I'm not going to create complete table because there is no need, but I will explain you the allowed and first forbidden. So it is like this. So for L equal to 0, S equal to 0, I want to create this. L equal to 0, S equal to 0, I am going to create this. So go to the last. So what you are saying first is allowed. Allowed. So you are talking about L equal to 0. Okay, first is allowed transition. So you're talking about L equal to 0. So two options are there. Option A, allowed Fermi. First option is allowed Fermi beta. ठीक है ना? First option क्या है? Allowed Fermi. Now it will be, try to understand. S is 0. So if L is 0, S is 0. So L is 0, S is 0. What you are going to have? You will have Ji will be equal to Jf. So whatever will be the value of Ji, that if that will be the value of Jf. And if you are talking about L is 0, then change in parity delta pi, that will be minus 1 to the power 0. So this will be positive. ठीक है? That will be positive. So delta L means parity is not going, means parity कैसे हुआ? अगर parity, change in parity, or you can say parity of this combined state. Even you can write in this way. I can show you. I'm writing this is the parity of the combined state. That is positive. ठीक है? So this is the equation for angular momentum. For parity conservation, this will be pi I equal to pi f and parity of the combined state. It will be like this. So what it will be? This is positive here. So this will pi f equal to pi I. So change in parity, no. There is no change in parity, no. So parity is not changing here. Try to understand, parity is not changing. Ji and Jf are not changing. L will be 0, S will be 0. So how can you recognize this L equal to 0, S equal to 0? It means parity is not going to change. In the given equation, parity will not change. So in this equation, parity is not going to change. And parity will not change, as well as Ji will be equal to Jf. For example, this type of transition, 0 plus to 0 plus. This type of transition, 0 plus state to 0 plus state. This is parent nuclei state, this is daughter nuclei state. This is parent nuclei state, daughter nuclei state. Or this will be 1 plus to 1 plus, or 1 by 2 plus 1 by 2 minus, suppose kuch bhi 1 by 2 minus. So this type of transitions, they are called as, ठीक है ना, allowed Fermi transitions. So here what is happening? Here what is happening? 0 to 0 transition is there. 0 to 0 transition is there. 1 to 1 transition is there. 1 by 2 transition is there. Parity is not changing. And parity is not going to change. तो parity भी change नहीं हो रहा. So they are the example of this allowed Fermi. ठीक है ना. ये जो transition है, sometimes it is highly probable. 0 plus to 0 plus transition you don't require, but the 0 plus 0 plus transition, this is highly probable transition. That's why sometimes it is not, it is also known as super allowed. Super allowed. So this is also called as super allowed transition. ठीक है. So that's why 0 plus to 0 plus, sometimes this is called as this super allowed transition. So this table here. So here, what I am writing, ये जो allowed है ना, I am dividing into two parts now. I will write super allowed here. In place of this, I'm just writing super allowed. So allowed may be classified into two. In many books you will find out, in other books you will not. So this is also allowed, super allowed. And here I am writing allowed. So super allowed is actually 0 plus to 0 plus. This is called as super allowed. Okay? This is called as super allowed. So here 0 to 0 transition is there. This will be delta J will be 0 and this will be no here. Here it will be 0 and it will be no. Their selection rules are same. But 0 to 0, 0 plus to 0 plus, this is highly probable transition. That's why some people call it a super allowed. If 1 plus to 1 plus is there, or half plus to half plus, half minus to half minus transitions are there, they are just called as allowed. If someone is saying allowed, if option is not given as super allowed, then you can consider it as allowed. This is a part of allowed. Just for your information, I have written like this. Remember this, that there is no counterpart here. For GT transitions, there is nothing like super allowed. Super allowed GT transitions are not possible. Super allowed GT transitions are not there, are not existing. Okay? They are not existing. So try to understand this. Now, we were here. We want to further move. So next. Next is, this is allowed transition. Next, I'm second, you can say allowed GT transition. GT transition. So your rule is Ji, that is equal to Jf plus L plus S. Allowed is there, so this is L equal to 0. But because this is GT, this S will be 1 this time. So you can write Ji will be equal to Jf. L is 0, so I am removing it, plus this is, this will be 1 here. S is 1. So L is gone because L is 0. So here, this L is 0 here. So this will be transition. Now, I want to find out change. I want to find out delta J. मुझे change चाहिए. Simple change. What is the change in, or what is the change in Ji minus Jf? Yeah, Jf minus Ji. What is the change? Jf minus Ji or Ji minus Jf? I want to find out this. So for this purpose, क्या करें? For making it simple, ठीक है ना? I assume that this Jf is 2. ठीक है? So let us assume, मैंने क्या किया? I assume that this is 2. You can consider other. I'm just assuming it. Let. Then try to understand what will be Jf, Ji. What will be Ji? If this is 2, this is 1. So 2 plus 1 is 3. 2 minus 1 is 1. So Jf values will be 1, 2, and 3. They are the possible values. So what are the changes? J 2 minus 1. So try to understand delta J will be high. What? 2 minus 1 is plus 1. 2 minus 2 is 0. And 2 minus 3, that will be minus 1. You can also write Ji minus Jf. So what will be the delta J value for this allowed GT transition? That will be delta J equal to 0 plus minus 1. What will be the change in parity because L value is 0? So parity state of combined state, parity of the combined state minus 1 to the power 0, that will be positive. So this pi I will be equal to pi f, and this will be positive. This will be positive. क्या होगा? पॉजिटिव होगा. इंट्रिंसिक पैरिटी बता सकते हो? ठीक है, इंट्रिंसिक पैरिटी. चलो इतना ही रहने दो तुम. सो आई एम नॉट गोइंग इनटू दैट डिटेल. पाई आई इक्वल टू पाई एफ. So parity is not going to change here. In this case, parity will not change. So allowed GT transition, this is, you can say, and if this is, then delta pi is no. Delta pi is no. Then here, this will be 0 and plus minus 1. 0 and plus minus 1. ठीक है? And this will be no. This will be no. So if delta J is 0 and 0 plus to 0 plus is there, then pure Fermi will be there. 0 plus to 0 plus is pure Fermi. 0, and this is only super allowed. So here you can write note zero plus to 0 plus is super allowed or pure Fermi? Is super allowed, and pure Fermi, and pure Fermi transitions. ठीक है? For example, B here, if transition will be 1 plus to 1 plus, 1 plus to 1 plus. So delta J is 0. Remember this, delta J, that is 0. Delta pi is no. So this condition, ठीक है ना? ये क्या है? Delta J is 0, delta pi is 0 or no? Look here. 0 is here, 0 is here, no is here, no is here. So this is a mixed mode. ठीक है ना? This is a mixed mode. So this is allowed. This is allowed Fermi and GT transition. You call it as allowed mixed mode. What you call it? Allowed mixed mode. बेटा ये GT भी है और Fermi भी है. ठीक है ना? Both allowed and GT transition. Mixed mode है ये. So what I'm telling you, this is allowed. GT, yeah, allowed mixed mode you can write. Mixed means दोनों है. Mixed mode. Both Fermi and GT mode. Next is this plus minus 1. For example, see, I'm saying 0 plus to 1 plus. 0 plus parity is not change. And delta J is plus minus 1. Delta J कितना है? Plus minus 1. या तो plus 1 या minus 1. And delta pi is no. Delta pi is no. Delta J is plus minus 1. You are here. No is here. So what will be this? This will be pure. allowed GT transition. Pure allowed GT transition. This is pure allowed GT transition. ठीक है, so this will be. This is pure allowed GT transition. This is allowed mixed mode, and this is super allowed and pure Fermi. Is it clear to everyone what I am talking about?
सर
Yes, beta, please.
सर यहाँ पे सर जो हम पेरिटी निकलते हैं वो
Yes,
कॉम्बाइंड स्टेट का होता है ना।
combined state का
हाँ,
parity.
तो उसका सर पॉजिटिव निगेटिव पे डिपेंड करके हम जो पेरिटी से वो निकलते हैं सर।
Yes.
ओके
ठीक
सर।
है. We are finding here that the parity of parent and daughter nuclei is changing or not. I will give you the example. ठीक है, जो you are going to look into the parity of the parent nuclei and daughter nuclei. Either their parity is changed or not. What is JI? JI is the pi I is the parity of the parent nuclei. Pi F is the parity of the daughter nuclei. So I'm talking about the parities of X and Y nuclei. I'm talking about the parity of X and Y nuclei. Either they are changing or not. ठीक है, they are changing or not. Is it clear? You
यस
can
सर।
look here. When I'm saying parity is changing, I'm talking about these parities are same, pi I and pi f, or they are changing. ठीक है, I'm talking about pi I and pi f are same or they are changing. Because here you look, I'm saying pi I equal to pi f. And if I'm writing no, means their parity. If this is positive, this is positive. This is negative, this will be negative. Change means if one is positive, another will be negative. Or this is negative, this will be positive. Change means these parities are changing. So in this way, we have here created this first line. ठीक है, where is that one? Here, this will be. Here ये जो GT transition है corresponding to super allowed, this is not existing. Now come to the first forbidden here. Come to the first forbidden, L equal to 1, S equal to 0. So this will be first forbidden. Third is first forbidden. And first is Fermi transition. As you are saying first forbidden, when you are saying this is first forbidden, I'm saying L equal to 1. When you are saying Fermi transition, I'm saying this is S equal to 0. So what will be my equation? That will be Ji, ठीक है ना, equal to, this will be Jf plus 1, L is 1 plus 0. So 0 is gone here. So Ji equal to Jf equal plus 1. So this will be Ji, that will be equal to Jf, and this will be plus 1. So again, you can assume Jf equal to 2 or any. You can assume it at 0. This time you can assume 2 or 1 or 3, whatever you like. It doesn't matter. Suppose you are choosing Jf is 3, for example. Let. This time I'm changing it. Let it is. So what will be this Ji? What are the possible values of Ji? 3, this is 3, this is 1. 3 minus 1, that will be 2. 3 and 2 plus 1 is 4. So these are the possible values. What will be the change? Delta J. If you find out delta J, 3 minus 2, that is 3 minus 2 plus 1. ठीक है, 3 minus 3 is 0 and 3 minus 4 is minus 1. So again this. But this time parity is changing. Try to understand pi I equal to pi f, and this will be minus 1. What is L? L is 1. So pi I is equal to pi f, and minus 1 to the power 1 is negative. negative. So if you are choosing it as plus, and here this is already minus, so what you are going to fill so that parity is conserved? This will be negative here. If you are choosing this negative and you want to make this equal, then this should be plus. So parity is changing. If you look at it was negative to positive, positive to negative, it means change in parity is yes. Parity is going to change. This will be. So parity is changing. So parity is changing.
सर
Yes, beta. Just
सर here सर प्लस इक्वल टू माइनस माइनस से माइनस इक्वल टू प्लस माइनस वो वाला लाइन समझ नहीं आ रहा.
yeah, 3 minus 2 is how much? This is 3 minus 2. Next will be 3 minus 3. 3 minus 4. This is delta J, na? So this will be plus 1. This will be 0. This will be minus 1. So only 3 possibilities, 1 to 1. So change, what can be the change in this J? It may be plus 1, it may be minus 1, or it may be 0. So 3 possible changes are here. Okay? So here 3 possible changes are here. Is it clear what I'm saying?
Yes sir.
Good. So basically here you have created the rules for this. So this will be 0. However, remember this, you're going to find out that in books it is written like this because this is very less probable. Very, very less probability is there. This will be plus minus 1 and this will be yes. This time this is yes. So when L equal to 0, this will remain no. You will look when L equal to 1, it will be automatically yes. From the equation you can observe. If L equal to 2 minus 1 to the power 2, that will be plus. So automatically it will be, there will be no change in parity. If I want to fill it, if L equal to 3 minus 1 to the power 3 is negative, so that will be change in parity. This will be yes. So you can make your table like this, L equal to 4 minus 1 to the power 4, that will be positive. So positive means this pi I will be equal to pi f. Okay, positive means pi I equal to pi f. So this will be no, there will be no change in parity. Here, no change in parity. It will be like this. Now, first forbidden L equal to 1, now GT transition. This L equal to 1 and GT transition, what it will be? Okay, this is a GT transition and first forbidden. So how can you do this? Okay, this will be next. First forbidden GT transition. Fourth is first forbidden. First forbidden GT transition. First forbidden GT transition it will be. So if you calculate it, okay, if you are going to calculate it, then remember this first forbidden, as you are saying, I'm choosing L equal to 1. As you are saying GT transition, I'm choosing S equal to 1. So what will be, this will be Ji, and Ji is, sorry, this Ji will be equal to Jf and plus 1 plus 1. It is like this. Okay, plus 1 plus 1. If you are choosing plus 1 plus 1, so what are the possibilities here? Try to understand. This will be Ji. This will be Jf. So here, there will be a possibility of 0, 1 and 2. 1 and 2. 0, 1 and 2. There will be the possibility. Now Jf, for assume, I assume Jf. Jf is suppose 3. You can assume anything. Let. maximum values you will get for JF. Maximum change is whatever possible. You have to choose JF greater than 2. For less, some of the changes will be find out. So JF is 3. So you can take the combination of 3 and 0. What you will get? You will get, so change in value I am finding 3 minus 3 and 0. They will give you 3. ठीक है ना? 3 here. So try to understand this. I'm choosing this as 3. So what are the possible values if I'm taking the combination of 3 and this 0? First, I'm taking this combination. So what are the possible values of Ji? Ji will be only 3. If I'm taking second combination 3 and 1, then Ji will be 3 and 1. What you will get? 3 minus 1, you will get 2, 3 and 4. You are going to get this. Combination of 3 and 1, what values of Ji it is going to produce? 3 and 1, 2, 3 and 4. Now this is 2 and 3. So 3 and 2. So this will be Ji. Possible values will be 3 minus 2, that will be 1, 2, 3, and 3 plus 2 is 5. So 4 and 5. Maximum values you are going to get this. Now changes. Now this is 3. Find out change. 3 minus 3, that is 0. 3 minus 2, that is plus 1. 3 minus 3, 0 is already here. 3 minus 4, that is this will be minus 1. So this will be plus minus 1. I should write like this. So this 3 minus 2 plus 1. 3 minus 3, that is 0. 3 minus 4, this is minus 1. So you are getting this. Now look here, 3 minus 1, this will be plus 2. 3 minus 2 plus 1 is already here. 3 minus 3, 0. 3 minus 4. I'm writing like this. 3 minus 1, that is plus 2. 3 minus 2, that is plus 1. 3 minus 3, that is 0. 3 minus 4, minus 1. 3 minus 5, minus 2. So these are the possible values. So this is delta J. So this is the delta J. Now, change in parity. What is the value of L? L is 1. So pi I equal to pi F minus 1 to the power. This will be 1. Minus 1 to the power 1. This will be. So it will be how much? This will be pi I equal to pi F, and that will be minus negative. So if this is positive, only two possibilities are there for pi I, either positive or negative. So what will be these? Fill in the blanks here. If you write, if this is plus, this is minus. So on this side, this would be minus. Only then right hand side will be plus. This is minus, this is minus, so it should be plus. So if you look at these parities, they are changing. ठीक है ना? They are changing parities. So yes, parity is changing. Delta pi is yes. Yes, parity is changing. So from here, you can find out yes, parity is changing. तो parity change हो रहा है बेटा. Next, you can fill it here. So this will be 0 and plus minus 1 and plus minus 2. It will be like this. Plus minus 1 and plus minus 2. If you, in the similar fashion, if you move, I'm not going to drive everything here. So I'm writing here, this will be 1, okay, and plus minus 2. If I fill here, in this way you can remember, that's why this will be plus minus 3. You can write first forbidden plus minus 1 is dominating, second forbidden plus minus 2, third forbidden plus minus 3, fourth forbidden. They are weak transitions. Here, they are very weak. Plus minus 4. On this side, it will be plus minus 2 and plus minus 3. This will be plus minus 3 and plus minus 4. This will be plus minus 4 and this will be plus minus 5. This will be. So this type of table is here. With the help of this table, you can always predict that the given equation, ठीक है ना, given transition, they will give you a transition, they will ask you to find which type of transition is this. ठीक है? So you have to find out the type of transition here in this. I'm writing some transitions and you are going to tell me. Please note it down quickly. First, note down.
सर कैलकुलेशन वाला स्लाइड एक बार दिखा दीजिएगा।
Okay,
थैंक यू सर।
welcome, Peter. So here I'm writing uh, 3 equations. Example, tan C6 0 plus this type of equation they will provide you tan B5 and this will be 0 plus. Second is suppose 34Cl. रटना नहीं है इन्हें. Don't remember these equations. No need to remember. Just by observing 0 plus you have to predict. 34Cl 17 here and this will be 0 plus and I should write this also on this side 4 and 5. This will be 6 here, this will be 5 here and this will be 34S16 and this will be 0 plus. So 0 plus to 0 plus transition, what do you call it? Super allowed pure Fermi. So what type of transitions are these? Super allowed pure Fermi transition. Super allowed pure Fermi transitions. ठीक है ना? Super allowed pure Fermi transitions there. ठीक है ना? This is first example. You can take it as first. Now second, 2He6. This will be 0 plus to 3Li6 and this is 1 plus. 1 plus. For example, another is 5B13. This will be 3 by 2 negative. 6C13 and this is 1 by 2 minus. Third, I can write 50SN. This will be 1, 1, 1 and here this will be 7 by 2 plus. And then this will be 49 IN triple 1 9 by 2 plus. This will be, you are going to tell me what type of transition is this. Bolo beta delta J is how much? 0 to 1, change is 1. 3 by 2, 1 by 2, that is change of 1. 7 by 2, 9 by 2, change of 1. So here you can write delta J is plus minus 1. Parity change, no, parity is not change. Positive, positive, negative, negative, positive, positive. Delta pi, no. So what type of this transition? This is allowed Fermi and this will be pure Fermi. Mix नहीं है ये, pure Fermi transition. This will be. Is it clear? Are these examples clear? Hello? Are you there?
Yes, sir.
Good. Then next, third example.
Sir, can you please show the previous slide?
Okay, beta, please.
Delta J means
Delta J means change in parity of parent and daughter nuclei. So you are comparing that change. You are comparing in the parities of parent nuclei X and daughter nuclei Y. ठीक है? Pi I and pi F, they are same or different? Pi I or pi F, they are same or different? If same is there, then parity is not changed. If pi I and pi F, they are opposite, then you are going to say that they are changing. Okay, I'm writing here if
Sir, isn't this allowed GT?
Fermi is GT,
Yes,
it
plus
will be
minus
correct.
two.
You are sure? This is GT, pure GT. Sorry, please. This is plus minus 1. Na? You can, he is correct. This is plus minus 1. So we are here in GT. So this is pure GT. Now we can go to the next. Please write. Later on, you can take the pics. N neutron 1/2 plus 2 proton. That will be 1/2 plus. Second, 1h3, for example, that is 1/2 plus. So wherever you are having confusion, you can ask. Sometimes when we are teaching continuously, it happens we are speaking correctly sometimes, right? Some errors will be there, so please find out those and mention. 7 and 13. 1/2 minus, and this will be 6C13. 1/2 minus. Something like this. 11 Na. 21. 3/2. That will be 3/2 plus. And this will be 10 Ne. 21. 3/2. And that will be plus. Okay? This will be. So here if you look at delta J, that is 0. Throughout all these transitions, delta J is 0. Parity is changing? No, parity is not changing. So delta J is 0 and parity is not changing. So what you are having here, we are here. Look here, we are here. 0 is here, 0 is here, no is here, no is here. So both the conditions, Fermi condition as well as GT transition conditions are satisfied. So both are possible. So mixed mode. So this is what? This is allowed mixed mode. This is allowed mixed mode. This is allowed mixed mode. Mixed means both Fermi and GT. Okay, this was another example. Next, fourth.
सर
Yes, but please.
सर वो सो 3/2 प्लस ये सब वैल्यू एग्जाम पे दिया रहेगा या फिर हमें वो सेल मॉडल से निकलना
No,
पड़ेगा?
no, they will provide you. ठीक है ना?
ओके
They
सर.
are going to provide you. In all the questions asked up to this point, they are given in the paper. And they will give you. So next example, that is fourth. n or 7n.
Sir, previous slide, sir.
Just 1 minute, beta. 17. 1 by 2 minus 8 or 17. And 5 by 2 plus. Second is, this is 35 BR. BR 76. And this will be 1 minus 2. 34 SC 76. So this will be 0 plus. And then 51 SB 122. This is 2 minus. This will be 50 SN 122. And this will be 2 plus. Okay, you are going to tell me. Please note down these. I will show you the earlier slide, last slide. Just note down these. So here 1 by 2, 5 by 2. What is the change here? Delta J is plus minus 2. 1 and 0. Delta J is plus minus 1. This is delta J is 0. Parity changing minus to plus, minus to plus,
Sir,
minus
delta
to
J
plus.
means the phi
Yes,
I
but
minus phi f. So phi I means 7.
no,
Or
it
phi
doesn't matter. Don't go into this. What is the change? 1 by 2, 5 by 2. So change of 2 is there. Either plus 2 will be there or minus 2 will be there. So don't think in that way because it's not making any difference. Either it is plus 2 or minus 2. So delta pi. Otherwise, it is JF minus JI. It is JF minus. If you want to think in that way, JF minus JI. Delta pi is yes. Delta pi is yes. Delta pi is yes. So what can you say? This is first forbidden. Okay, parity is changing. Okay, try to understand where you are. Parity is changing. You are here. Parity is changing. Yes is here. Either it is 0 is here, plus minus 1 is here, plus minus 2 is here. Okay. So if plus minus 2 is there, this is pure GT. Okay. For other two, that is a mixed mode. So for plus minus 2, this is pure GT. First forbidden pure GT. So this is first forbidden pure GT. They are mixed mode. First forbidden mixed mode. Mixed means both.
Fermi and GT.
Yes, beta. Both Fermi and GT. This is also first forbidden. But most of the time they don't go into so detail. They will give you, and in options they will write just first forbidden, second allowed. They will write like this. So they don't go into so deep, but I'm telling you because I'm discussing mixed mode. So it will be like this. So this is the example of first forbidden.
Can you
Please
show
note
me the
it.
previous slide?
Yes, beta. Please write.
Okay, sir.
Okay. This is the next one. Can I go to next page?
Yes, sir.
Okay. Next, this was a fourth and then this will be fifth example. These are the examples, just I'm writing 11 Na22, 11 Na22, and this will be 3 plus 2, 10 Ne22, 10 Ne22, and this will be 0 plus. I'm writing this example. So don't remember these examples, just learn how to find out the name, type of transition. 55 CS, 55 CS, and this is 137. That will be 7 by 2 plus 2, 56 BA, BA 137, and that is 3 by 2 plus 3 by 2 plus, it will be 3 by 2. You're going to tell me here what they are. If you look at this first one, okay, first one, if you look, here 3 to 0, so delta J is plus minus 3. If you look here, 7 by 2 to 3 by 2, delta J is plus minus 2. And parity plus 2 plus, plus 2 plus. So delta pi is no. Parity is not changing. No. Delta pi is no. So plus minus 2, plus minus 3, and no. Plus minus 2 and plus minus 3 and no. Find out in table. So no is here. Okay, no is here. Plus minus 2 and plus minus 3. Plus minus 3 is not here. So this is pure GT. But plus minus 2, that will be a mixed mode. Okay, so second forbidden. Okay, na? So what it will be? Second forbidden. So this is second forbidden. This will be pure GT. Pure GT transition. And here this is second forbidden mixed mode. Okay, this will, because plus minus 2 is there in both, in Fermi as well as in GT. So that's a mixed mode. Mixed means both. Next, please note it down quickly. Next, example 6. That will 37 RB87 and 3 by 2 minus 2, 38 SR, 87 and 9 by 2 plus. Second is 19K40 and this is 4 minus 220 CA40, 0 plus. So if you look here, 3 by 2, so this will be 6 by 2 plus minus 3, delta J is plus minus 3. Here delta J is plus minus 4. Parity is changing? Yes, parity is changing. Yes, delta pi is parity is changing. So you can look into the table. This is fourth forbidden. This will be delta J is plus third for कितना होगा ये? Third forbidden. ठीक है ना? This will be third forbidden. Yes है ना? So parity is changing. So how can you remember parity is changing? So this will be some L will be odd number. So this is third forbidden. So you can write third forbidden. Forbidden both. This and this. Third forbidden. In exam, you have to just write it. Forbidden. And if you look at this, this is pure GT transition. And if you look at delta plus minus 3 is in both, so this will be mixed mode. Mixed mode. This will be. Last, I'm writing here. This is 49 IN indium 115, and that is 9 by 2 plus 2 22. This is 50 SN 115, and what is 1 by 2 plus 1 by 2 plus. So what is delta J? That is 4 here, plus minus 4. And what is parity change? Delta pi. ठीक है ना? Delta pi is no. And delta plus minus 4 will be in both. So this will be a mixed mode. So this will be fourth forbidden. Mixed mode. So these examples were with me. So I have discussed most of the aspects of this beta decay. Okay, so for today, I am going to stop here. In the next class, I will discuss the questions related to this beta decay and neutron problem. Okay.
Sir,
Okay,
for
beta.
example number 6 show कीजिए.
Which one?
5th.
Okay.
Okay, sir.
Okay, beta. Thank you very much, beta.
Thank you, sir.
Welcome, beta.
Thank you, sir.